Welcome to this video on shell scripting in Linux. We will cover the basics, how to write and execute scripts, and how to use advanced features like piping. So what is a shell script? It is a text file containing a sequence of shell commands that are executed in order. At a basic level, scripts start with a hashbang line and can include variables, input, conditions, and loops. For advanced scripting, you can use parameters for direct input, create functions to organize commands, and implement automated error handling and additional security validation. You have several options for text editors. Nano is ideal for beginners, while Vi or Vim provide a more comprehensive, standard experience. On desktop systems, you can also use graphical editors like Gedit or Kate. When using Nano, save your work by pressing Ctrl+O, then enter and exit with Ctrl+X. In Vi or Vim, press I for insert mode, then use WQ to save and exit, or Q to exit without saving. For graphical editors like Gedit or Kate, use standard save shortcuts like Ctrl+S. Remember to always save your script with a .sh extension and store it in an easily accessible location. Next, let's look at piping, represented by the vertical bar symbol. Piping connects the output of a command on the left to the input of a command on the right, which is both fast and efficient. When writing pipes, use the syntax command_1, command_2 feet. It is recommended to include a space before and after the pipe symbol to make your code easier to read. Here are some simple examples of piping: using grep to filter files, using sort to organize disk usage, or checking if a specific partition is mounted. This is how you can incorporate piping into a shell script. This example uses grep to check a mount point and returns a status message accordingly. An important note regarding piping is that it only passes standard output, not error messages. Also, you can chain more than two commands together in a single sequence. Every script should start with the correct hashbang structure. To run your script, remember to set the execution permission using "chmod+x" and then run it using /. Keep in mind that shell commands are case sensitive. Always ensure you include spaces inside square brackets for conditions and use quotes if your text contains spaces. Parameters or arguments allow you to pass values directly when running your script, eliminating the need to provide input interactively. Finally, use these special variables: $0 for the script name, $1 and $2 for input values, $@ for all inputs at once, and $# for the total count of arguments provided. Let's look at parameters and arguments. This example demonstrates how to use the $, followed by a number, to represent variables passed to your script, such as the script name and the device being checked. Functions in shell scripting allow you to group commands under a single name, making them reusable throughout your code. This structure helps keep your scripts clean, organized, and much easier to maintain. To define a function, use the name followed by parentheses and curly braces. Inside, you can declare local variables to ensure they do not conflict with the rest of your script. Here is an example showing how a function can be used to check for required packages. This script verifies the existence of a tool and installs it if it is missing. Effective error handling is vital for robust scripts. The special variable $, returns the exit status of the previous command. A value of 0 indicates success, while any other value signals an issue. You can use this exit status to control the script flow. In this example, we attempt to mount a drive and provide feedback based on whether the command succeeded or failed. For shorter logic, you can use the double pipe operator. This tells the script to execute the subsequent commands only if the preceding command fails. Now let's review a more complete example. Here we create a script that automates mounting an NTFS partition, incorporating the function and error handling concepts we just covered. In this section of the script, we define a function to ensure the necessary package is installed, using "" to check for it and " to handle the installation if needed. Next, we add a function to handle the mounting process itself, which includes creating the mount point directory and attempting the mount command with proper error reporting. The final part of the script calls these functions in order to perform the check and then mount the specified partition. Always remember to make the file executable with chmod. If you need to debug or learn more, use commands like man-nano for documentation. You can also use --n to check for syntax errors without running, or --x to trace execution steps. Keep these best practices in mind. Always use the sh extension, favor local variables within functions to prevent errors, and use sudo only when administrative privileges are required. To summarize, use reliable text editors, maintain a consistent structure with hashbangs and comments, and implement clear error handling to ensure your scripts are reliable and easy to debug. By mastering parameters, functions, and error handling, you can write powerful automation tools. Start with small, simple scripts, and gradually add complexity as your confidence grows. Thank you for watching this video. We hope you found this guide to shell scripting helpful. If you enjoyed the content, please like, follow, and share your thoughts in the comments below.